Hello and welcome to part 2 of module 2 in our Django series. In today's session, we're going to discuss view decorators, class-based views, and error handling. Let's begin with view decorators. What are they? Essentially, view decorators allow us to restrict access to our views. Now you may ask how? Well, every decorator has a condition or conditions that need to be met, and if they're not met, an error is returned. The type of error returned is the HTTP response not allowed error, which returns a status code of 405. Now let's go to our code and introduce a view decorator. To do that, go to your command prompt and then change directory to your virtual environment. And of course, we need to activate the virtual environment. We can start Visual Studio Code from this point. We will introduce a view decorator now to this view, the date and time view. All we need to do is type in there @login_required. And that's all. Now there's a squiggly indicating we need to import login required. So from django.contrib.auth for authentication .decorators import login required. Let's now go to our browser and access this view. But to do that, of course, we need to start the development server. So change directory to your container folder. Type in py manage.py run server. Right, this will start the development server. And now we can go to our browser and type in there localhost, right, 8000 / our app name /date time. Press enter. It says Django tried these URL patterns in this order, but did not find accounts /login/. Right, so this is to do with authentication. Now we haven't learned about the Django authentication module. So to resolve this error, what we'll do is we'll use the login URL. So just open a bracket there and put in login_URL equal to, and here we'll specify a view to use. So that will be / the app name / the view name. And of course, we need another slash there. Now we will define this view, right? And that's going to take the HTTP request object, of course. And all we'll do here is return a message. Now that we've created this view, we need to wire it into our URL configuration. So come to your app urls.py file and make sure there's a comma there. Right, and then put in path, and this will be display_message / comma views.displayMessage comma name equal to displayMessage. Okay, so now let's try to access the view again and see what happens. So here we just put in the app name, date time, press enter, and now you see the message. Okay, spelling is wrong, but you get the idea, right? Now let's talk about class-based views. So far, the views we've written are all, if you look at our view definition, they're all function-based, starting with def indicating a function definition. Django, though, also allows us to use Python objects to create views instead of functions. Now, what's the advantage of using objects? Well, of course, they can be reused, right? This makes class-based views, therefore, more extensible and flexible when compared to function-based views or FBVs. The common thread that runs through both function-based views and class-based views is that both of them need to receive an HTTP request object and then return an HTTP response object. The difference between class-based views and function-based views is that all class-based views have an asView method. Now, what this method is about, to understand that, we need to discuss the base view class. All class-based views inherit from this base view class. And essentially, it's spelled with a capital V and it's imported from Django.views. This base view class has two important methods, the setup method and the dispatch method. And now we'll see the role that these two play along with the asView method when we discuss how the Django URL resolver works. It's important to remember that the Django URL resolver will only send the request and arguments to a callable function. It's not ever going to send the request and keyword arguments to a class. How then are class-based views managed if a function is required? And that's where the asView method comes into play. So the asView method returns a function which is callable. So when a request for a URL that matches a pattern arrives, then it is this function that is called. And this function in turn will first create an instance of the class, then call the setup method. What does the setup method do? The setup method will do some view initialization, initialize attributes. The same callable function will then call the dispatch method of the class. And the dispatch method in turn will first look at the request, then determine whether the request method is a get, post, put, delete, etc. and will then either relay the request to the matching method or raise an error. What type of error? Again, it's the HTTP response not allowed error. So that's how class-based views work. Let's go ahead and add class-based views to our code. We'll put in a function-based view and then compare that code with a class-based view. We're going to have the function-based view. First, I'm just going to call that FBV, and that's going to take the HTTP request object. And here we'll have a variable, my name equal to, and you can put in any value you like. And we say if, now if we need to check what type of method comes through this request, we have to use the if statement in a function-based view, and that will be if request dot method equal to a get, then we'll say return HTTP response. And we just say there hello and the variable. Right, now how would we do the same thing using a class-based view? We start the definition with class, right? And we're going to call that CBV. Remember, class-based views inherit from the base view class, and that's a capital VIEW. And of course, we have a squiggly there because we've got to import it. So from Django.views, import view, right? And here, first of all, the attribute my underscore name equal to, and I'm going to put in some other name there, right? Now here in a class-based view, we don't have to use an if statement to check for the request method. Rather, we just need to put in a function definition for each method that we're going to use. So we have get here, right? And the first argument is always self, that's by convention. And self essentially will allow us to reference the attributes of this class, as we will see shortly, right? So self, comma, and then of course we need the HTTP request object. That's common, remember, for both FBVs or function-based views and class-based views. And then we'll return HTTP response, and this will be hello plus self dot my name, right? Okay, so that's how we can reference that attribute. So you see the difference in the code. Now, of course, we've got to wire these two in. So come again to your app urls.py file and make sure there's a comma there, and then put in path, and this will be fbv for function based view / comma views.fbv, right, comma name equal to fbv, right, and a comma there. And now we'll put in the path for the class-based view. So for the class-based view, this will be cbv / and now we need to use the as view method. So here we will say cbv dot as view, right? Now we have a squiggly there because we need to specifically import cbv. So from school app, that's the app name, as you know, dot views import cbv. Okay, and then of course you can include the name parameter, name equal to cbv. Now let's go ahead and try to access these views. So here we will put in / fbv, and you have that name. Put in cbv, and you have the other name. Right, so I hope you've understood how class-based views work. Now let's look at the benefit of having this class-based view. We can reuse cbv, for example, how we can set the attributes to have a different value and then have the class we're going to define inherit from cbv. So this is how we do it. Class child, let's call that, which is going to inherit from the parent, which is cbv. Okay, so we're getting that squiggly here because of the indentation. Remember, Python is strict on indentation. And so here we'll just set the attribute name equal to some other name. Okay. And now we can just wire this view into the URL configuration. So comma path child / comma child dot as view, and again we need to import child, so comma child, right? And then you can use name as well, name equal to child. Now we can go to the browser and try to access child. So here just type in child instead of cbv, press enter, and you see the name we just put in, right? Now there's another way we can do this, and that's directly through the URLs. So we don't put in anything into our views file. We can set the attribute directly in our urls.py. How? Make sure there's a comma there, and then put in path, and let's call that child2 / comma, and here we'll say cbv dot as view, and within these brackets we will set the attribute. So my name equal to John, and then of course you can include the name parameter. Now let's go and try to access child2. So just change that child to child2, and you should be able to see the name, right? So I hope you've understood that. Now, what if we wanted to use a view decorator on a class-based view? To use a view decorator, we can't really do it the same way as we do for function-based views. What we can do is, first of all, in our urls.py, let's use CBV for this. Here we can just put in login required and then close cbv.asView within those brackets, right? And of course, we need to import login required, therefore the squiggly. So from django.contrib.auth authentication dot decorators import login required. And in addition to this, we need to set the login URL in our settings.py file. So come to the bottom of the file and we can add in here in all caps login underscore URL equal to, and then of course we can specify the view, right? So that would be / the name of the app / the name of the view. So now if we try to access CBV, okay, so now we have this screen. Why? Sometimes when you make changes to your settings file, right, then the server automatically terminates as you're making these changes. Just start that server again and then refresh the page. And there you see this. Now again, there's a spelling, but you know exactly what's happening, right? Okay, so that's about class-based views. Now, having learned class-based views as well as function-based views, it's a good time to talk about the Django REST framework. Now, Django has its own REST framework built on top of Django. We're not going to go in depth into Django's REST framework during this series. That would require a separate series altogether. But for those who are not familiar with the term REST, the full form is representational state transfer. And these are a set of guidelines that were created by the scientist Roy Fielding in the year 2000. Using these architectural guidelines, developers can create reliable web APIs, which are frequently referred to as RESTful APIs. To give you examples, Twitter uses RESTful APIs, so does Facebook. Instagram uses their own RESTful APIs. You have Google Maps using RESTful APIs as well, Salesforce too, WordPress as well, and you can see how popular it is. Before the REST guidelines were created, there was the protocol SOAP, right, or Simple Object Access Protocol. But today, REST is preferred for many reasons. One, the APIs created are lightweight when compared to other APIs created using SOAP. Secondly, REST supports the JSON format, whereas SOAP does not. And remember, the JSON format is easy to code with, easy to read as well. Mobile application developers prefer REST simply because page load is faster. Remember, with mobile applications, even a few seconds make a difference. But coming now to the basis of REST, that is requests and responses. And so REST essentially leverages HTTP. We have the client, which could be a laptop or a mobile. And we have the server. And then, of course, we have the API. It's always the client that will send a request through the API to the server. And the server will always send the response back to the client. Nothing about the client session is stored on the server, right? So this results in a loose coupling between client and server. The client interface, therefore, is independent of data storage. This results in the client interface then being more portable. Now, talking about the Django REST framework, and in terms of the views we just learned about, that's class-based views and function-based views. The Django REST framework supports both. Now moving on to error handling. All error handling in Django is done through views. These views are built into the framework. When are they invoked? They will be invoked, for example, if Django encounters the error URL not found, or if another exception occurs. So by default, for the URL not found error, this is the view that will be called, right? And that view is built into the framework, as I said. Now you can create your own custom error handling views. You would normally not need to, unless of course you've got to do error logging as part of your project brief. In that case, you would have to use certain specified variables. So for example, for the URL not found, you would have to use handler 404. All the views to use are specified through variables, and there are 4 of them. We've got handler 400, handler 403, handler 404, and handler 500. So let's look at these in a little detail. So if, for example, you're checking for a bad request error which returns a status code of 400, you would use handler 400, right? So that's the variable specified. If you're checking for permission denied, right, which returns a status code of 403, then you would use handler 403. If you're checking for the error no URL pattern match, which returns a status code of 404, you would use handler 404. And if you're checking for a server error, which returns a status code of 500, then you would use handler 500. Important to note that custom error handling views will not be used by Django if debug is true. So let's talk a bit about debug now. By default, debug is true. How do we know? We can go to our settings file, and if you scroll up, you will see debug is set to true, and also a security warning: don't run with debug turned on in production. So let's understand why. When debug is set to true, error messages are displayed, as we've been seeing so far, right? And this is very useful in our development environment or our testing environment. But when we are in the production environment, the debug output could include settings, and among them may be file paths, configuration, etc. Now this is all sensitive information, and displaying all this on screen to the user would of course make your server susceptible to attack. So that's one reason why you would never have debug set to true in the production environment. The other reason is that when debug is set to true, Django will remember every query it executes. Now, if you have debug set to true in the production environment, this is going to negatively impact server memory. Therefore, never deploy a site into production with debug set to true. So this ends our session for today, as well as module 2. In the next session, we'll create the models for our application. So till then, take care. Bye.